Alright guys, we are now looking at target 4.6. Our mastery learning objective is I can find conditional probability by dividing simple and compound probabilities. So what is conditional probability? Conditional probability is the probability an event will occur given another event has already occurred. I think there's two R's. We'll pretend there is. That doesn't look right either. I don't know. Okay. So probably an event will occur given another event has already occurred. So the best example is, right, passing a test, right? What will be the probability you pass the test given, right, something, right? So either you studied or you didn't study. So the probability that you will pass the test given you studied is most likely very different than the probability you'll pass the test given you didn't study. Okay, so this conditional, it changes based on what's already happened. So then, probability of the event B given event A. And we write B first because event A has already happened. So in the timeline, A came first, and then we're seeing what B is. So B given A, this line here, we would say this as given, so the probability of B given A equals the probability of A and B divided by the probability of A. Okay. So it's very important to know which one is B and which one is A. So let's look at an example. First, we're just going to do it with numbers, so we don't have a situation here. So we have the probability of A is 0.64. The probability of B is 0.54, and the probability of A and B is 0.14. Find the probability of B given A. Well, again, the probability of given A equals the probability of A and B over the probability of A. Right, that's our formula. And the probability of A and B is 0.14. Hold on. Let's try this again. There we go. And the probability of A, our probability of A is 0.64. And so if I divide those, I'm just going to use this calculator. And we'll round it to, these are 2 decimal places, so we'll also round to 2 decimal places, 0.22. And usually we keep our answer in whatever form it was given to us. So it was given to us as decimals here, so we'll keep it as a decimal. All right, let's look at our second example one. I guess I didn't change the numbers there. In school, the probability of, or the probability that a student takes environmental science and geography is 0.25. The probability that that a student takes environmental science is 0.72. What is the probability that a student takes geography given that the student is taking environmental science. This last sentence is important. So we're finding the probability that a student takes geography given that the student is taking environmental science. So we're doing the probability of geography given can't spell today all environmental. And it's okay to, like I said, it's okay to abbreviate. Like I'm not gonna write student takes geography given student takes environmental science. That's too much. So I could even do like geo, envir, like it's okay to abbreviate all your things. Okay? So this is what we're finding. That means this is B and this is A. So it's important to know which one's B and which one's A. And that's going to be this, right? Then we want the probability of A and B. Environmental and geography. Over, right, the probability of A, the probability of environmental. As you're doing this, you really want to write down all these things. It makes it a lot easier to find. And make sure you're not making any mistakes. So probably environmental and geography, well, the probability that a student takes environmental science and geography is 0.25. And then the probability of just environmental, that a student takes environmental science, is 0.72. Dividing those, I get 0.35 about. And we'll keep our answer like that because that's what it was given to us in decimals. Okay, let's look at our next example. The probability that Susie does her economics homework and her math homework is 0.42. The probability of her doing her economics homework is 0.62. The probability of her doing her math homework is 0.72. What is the probability of her doing her math homework given that she does her economics homework? Okay. So, the probability of math given economics, right? I'm abbreviating, right? So that means this is our B and that's our A. So it equals the probability of A and B, so econ and math over the probability of A. The probability of econ and math is 0.42. And the probability for her doing her econ is 0.62. Okay? And that's all we need. You'll notice that this probability we're doing for math homework, we don't need that, right? We don't need the probability of just B. It's given to us, and that's great, but we don't need it. So then we have 0.42 divided by 0.62. That's 0.68. All right, let's go ahead and turn the page. So in a box are a carton of Dairy Milk and Boonville chocolates. 2 chocolates are chosen at random. The probability of choosing a Dairy Milk and a Boonville chocolate is 47%. The probability of choosing a Dairy Milk is 71%. And the probability of choosing a Boonville chocolate is 67%. What is the probability of selecting a Boonville chocolate given that can say a Dairy Milk was already chosen? So this is what I'm finding, right? Probability of selecting Boonville given dairy, right? So again, that means this is B and this is A. So then the probability of A and B means dairy and Boonville divided by the probability of dairy. So the probability of dairy and Boonville is 47%, so that's going to be 0.47. And the probability of choosing a dairy is 71, so that's going to be 0.71. Alright, make sure that it is into your decimal form or whatever when you are dividing. So you have 0.47 divided by 0.71, and that gives us about 0.66, which equals 66%. Then example 4, in Mr. Jonas' homeroom, 70% of the students have brown hair, 25% have brown eyes, and 5% have both brown hair and brown eyes. A student is excused early to go to a doctor's appointment. If the student has brown hair, what is the probability that the student also has brown eyes? Okay? So this is asked in a different way. We still have to think about how I could rewrite it as our given probability. Right? If the student has brown hair, what is the probability that the student also has brown eyes? Another way I can say this is, what is the probability that the student has brown eyes given they have brown hair, right? So this if is the same as your what's after that given, okay? So here we're doing brown eyes given brown hair. So that's our B, and that's our A. So the probability of A and B would be the probability of brown hair and brown eyes divided by our probability of A, which is just the probability of brown hair. Well, brown hair and brown eyes, 5% have brown hair and brown eyes. So that's 0.05. Brown hair, 70% of the students have brown hair. So that's 0.70. So same type of thing, just kind of a different way of asking the question. So that's 0.05 by 0.7. Yeah, that'd be 0.05 by 0.7. We get 71. Right, 0.71, which is 71%. Again, our question gives us probabilities in percent, so we'll put our answer as a percent. Alright, looking at example 5. A bag contains 6 blue marbles and 2 brown marbles. one marble is randomly drawn and discarded. Then a second marble is drawn. Find the probability that the second marble is brown, given that the first marble drawn was blue. So this one marble is randomly drawn and discarded means that, right, it's not replaced. So we're doing a probability that the second marble is brown, given that the first marble is blue. So probably a brown given blue. Okay, it's blue. Equals the probability of blue and brown over the probability of blue. Well, the probability of blue and brown, well, this one, it doesn't tell me what that probability is. This isn't one of those where we have to find our probability. Remember, and tells us to multiply. So, probability of blue, well, there's 6 blue out of 8. Times, well, I discarded the 1 blue, right? So there's 2 brown, but since I got rid of one of my blue, there's now only 7. Okay. Divided by well, the probability of blue is 6 out of 8. Well, that's nice. That's 2 out of 7. So in this situation, if you look, right, I already found, right, my probability that the brown, I'm going to choose a brown given I already chose a blue, just based on knowing that, oh, my blue's away. Okay, it's 2 out of 7. So I don't even really have to do this formula when I'm given this situation, right? It's just the second half of your dependent probability that we did earlier. So if I look at number 6, you're playing a game of cards where the winner is determined by drawing 2 cards of the same suit. What is the probability of drawing clubs on the second draw if the first card drawn is a club? Okay. So I have my 52 cards total, right? I drew a club. So I originally had 13 clubs. Okay? If you think about, you can pull up that deck of cards. Now, since I've drawn a club, I now have 51 cards total with 12 clubs. So the probability of club given club is, this will be 12 out of 51. All right, I don't even have to really think about that whole formula. I know I already draw a club, and so I just have that. So if you're given the actual number of things, you can just think about it and like draw it out almost. All right, that is it.